Okay, so it's just the one example we're going to go through today. So we're taking our parent function. Okay, so this is the parent function. This base could change. Okay, so it could be a half, it could be a 2, it could be a 4, it could be a 5, it could be 1/3. The base does change. Okay, but we know it's the base because it's just the power of the x, and that's it. There aren't any other stretches or compresses. I generally use just these 5 values, no matter what the base is. I usually just use these ones. Okay, so -2, -1, 0, 1, 2. Okay, if you plug them in, you get these values here. So just to show you brief, actually I already did one of these yesterday lesson, right? So 4.5, I did this as an example where I show you I plug in the exponent. So -2 goes into the exponent. Okay, if it's a -2, it flips, which makes it 2/1 or just 2. And then 2 to the power of 2 is 4. Okay, so if you don't know how I got these values in the y, make sure you revisit yesterday's lesson. Okay, so the question asks to graph this function here. So I added a bunch of stretches, compressions, and translations to the parent function of a half so that we want to get now new values. So exactly like we did in chapter 1, okay, exactly what we did on the chapter 1 test as well. Okay, so what is the easiest way that I can now find these points? What would you do? To find the new points, what do I need to do? Adrian?
Use the mapping rule.
Yeah, reuse that mapping kind of formula. Okay, so it's the x over k plus d, and then our ay plus c. So I'm going to plug in our x and y. So our first one is -2, and our y value is 4. And now our a, k, d, and c we get from the equation. Okay, what is our k value? What is our k value? So let's go in order. We'll find our k first. People at home, you guys can answer as well.
There.
Yep.
Can you move that a little bit? It's like right in the glare. But,
Oh, the
graphic
formula,
is,
right?
Completely in the glare.
If I put it here, can you see?
Yeah, that's perfect.
All right, do that. So we're using the first point, which is -2, and then we have our 4 as our y value. Thank you for letting me know. Okay, what is our k value in this equation? Adrian?
0.5.
Oh yeah, that is right. Yeah, 0.5. I don't know why I was thinking 2. So this our k value is 0.5. So we have 0.5 as our k value. Okay, next is plus d. What is our d value here? Most of it is in the glare. It's fixed now, right, Marco? I don't have anything here. You see where? So that's the glare area, right? There isn't anything in there now. Okay. Okay, our d value? Declan? It is 3. Yeah, so we're a +3, so +3. Even though it's a -3 here, we remove it. It is +3. Okay, next our a value. A value. At home, you guys can answer as well. What is our a value in the equation? It's 2, good. So 2 is our a value. And lastly is our c value, which is +2 as well. And now we solve each one to get our new values. So we have -2 divided by a half is 4. This is 4 halves and 2. So -2 divided by 0.5 is -4, sorry. -4 plus 3 is -1. Then we have 2 times 4 is 8, plus 2 is 10. So we did the first point, now we just switch our x and y values. On the previous test, if you got one of these mixed up, I still give you pretty good marks as long as your math was right. Because if you got one of these incorrect, the A, K, or D, or C, then it threw all your points off, right? So I wasn't gonna give you 0 on those points, on those questions. So if you got one of the numbers mixed up, I maybe gave you a 3 out of 4, as long as everything else was correct. Okay, so now I switch to the next one, -1 and 2. So -1 divided by 0.5 is -2, plus 3 is +1. 2 times 2 is 4, plus 2 is 6. Just crossing the points as we go, just to make sure I get them all, I don't miss any. The next one is 0 and 1. 0 divided by 0.5 is 0, plus 3 is 3. 2 times 1 is 2, plus 2 is 4. Okay, I want you guys to do the last two. I'm seeing 5 and 3. That's the next one. Someone getting 5 and 3? Okay, going by the students' results, 5 and 3 is the next one. So 1 divided by a half is 2, plus 3 is 5. 2 times a half is 1, plus 2 is 3. Good. And next number is here. What do you guys got for the last one? What's the last one? Adrian, what you got? 7 and 2. 2.5. So 7 and 2.5. 3.5, sorry? You get 3.5.
Yeah, I messed it up.
Oh, 2.5?
Yeah, it's 2.
Last one? 7.5. Good. 7.5. Excellent. 7.5. Good. Everything done too? Yeah. Okay, the last one, what everyone was getting was 7 and 2.5. So now we're gonna plot it. So I'll just go by twos. By the way, you notice I didn't draw the graph right in the middle to start because I looked at my transformations. So I noticed that I was going 3 to the right and 2 up. Okay, so I made it so that it was more, I would see more of the right and the upper parts, just based on my transformations. Okay, now we just plot the points. -1 and 10, what's negative 1 and 10, 1 and 6, 3 and 4, 5 and 3, 7 and 2.5. So we get something that goes. By the way, you guys, if you do a test, I asked you to graph something, please put the numbers. My grade 12s are pretty bad at actually putting numbers. So make sure you have the numbers there so that I know your scale is correct. You don't have to do it now, but for a test. Any questions, guys? I'll go through, we'll find out the domain and range, and then we'll also find the asymptote. I only put the domain here. I think some other stuff got cut off. So I'll do the domain, the range, and the asymptote. Any questions at home? I'm just going to erase these here. All right, so let's do the domain. Okay, we start with XER. If there aren't any restrictions, then we just leave it as that. If there are restrictions, then we state them. So any restrictions with our X values. Any restrictions with our X values. You guys at home can answer as well. Is it just XER, or do we have to add something for our domain? Isabella, that would be for the Y values. That'll be for a range. Okay, it's our X values. So for X values, it keeps going this way. So we have a continuous, it's arrows. So it's all our positive values. And if this would keep going, then we'll have all our negative values would all hit the graph. Okay, so it's just XER. It's all our positive X's and all our negative X's. So it's just XER for our domain. And then Isabella at home said, our range is Y is greater than 2. And how do we know it's just greater than 2? How do we know that that this line doesn't go down this way? How do we know? Yes, who answered that? Isabel, yeah, that's the asymptote, okay? So the asymptote is always this value here. It's your C value. That's where your asymptote is gonna be. Okay, so we know that it's not gonna touch 2. Okay, in the parent function, it's 0, because there isn't a C value, it's 0. But if we shift it up or down, then our asymptote is the C value. So that's why our Y values is everything greater than 2. We do not put the equal to, because it's not actually going to touch 2. Okay, but what happens is the graph will keep getting smaller and smaller and smaller. It will keep getting closer and closer and closer to 2. So it'll be like 2.01, 2.001, 2.00001. Okay, it's going to keep getting very, 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 very close, but it'll never actually touch 2. So that leaves me with the last part for their asymptote. So our asymptote would be y equals 2. Okay, because that's where it crosses the y-axis at 2. Okay, so our asymptote is y equals 2. Any questions? No? Any questions at home? Questions at home? So what you get from the base, so the question is, do we need the base at all? So you notice that we didn't put the base anywhere in the equation. We don't need it. But what the base tells us is which way the graph is going to go. Okay? So this is a half. What do we know about the graph going left to right? What's happening to the graph? It's decreasing. So our graph is decreasing left to right because our base is between 0 and 1. Okay? If this was greater than 1, our graph would go the other way. So if we had, say, a base of 2, it would go this way. It would be increasing. Okay, so if it was positive 2, it would be going this way. It'd be increasing left to right. Okay, so but yes, to answer your question, you do not use the base within the actual mapping notation. Okay, when we're doing the map formula to find the points, you do not use the base. Good question. So the k-value compressions are greater than 1? Yes, that's correct. Remember, the k-value is always the opposite. So our k-value here is 0.5, but when we explain it, we flip it. So 0.5 is 1 over 2. So our k-value is 1 over 2, but we reverse it. So it becomes a 2. So it ends up being, this becomes a compression of 2. So your k-value, you always flip it. Okay, anything to do with the x's, it's always the opposite. So this goes the opposite way, so it's a -3 here, but it goes right. And then our k-value, we flip it. Okay, the homework. What was it there? Declan, page 251.
Yeah, 253.
53?
Yeah, 1 to 5, A and C.
1 to 5.
A and C, yeah. And 7 to 10.
It's A and C for all of them?
I think just
Yeah,
one.
all of them. Okay, so homework, page 251. It's all page 251, numbers 1 to 5, but for 1 to 5, you're just doing A and C. And then after that, 7 to 10. Okay, so the first couple are just explaining you're just explaining the transformations. By the way, one more thing I want to add. Oh, we don't have it here. If you ever ask you for the y-intercept, they ask you for the y-intercept, you just plug 0 into x. Okay, if they ever ask you y-intercept, plug 0 into x. Yeah, so the first 5 questions, you're just describing the transformations. Okay, then 7 to 10, you have to do a little bit of graphing or matching.